Hello, family. Welcome back to the channel. In today's video, we are going to look at how to use Echolon Matrix method in solving these systems of linear equation. So if probably by now you would have watched the LU decomposition method that was uploaded before this video. And if you haven't, please go back to that playlist and watch that particular video as well to give you a color to the difficulty of using that method compared to this method. Actually, these two methods are actually similar, but they diverge at some point. So you probably see the difference once you watch this video and compare to the previous video. Okay, so let's just get started. Let's get right into this. Now, we have these same systems of linear equations that we solved in that particular video. I want to solve this with Reduced Echolon Matrix method. So how do we do this? So this method, basically, we start with from the same point. We have our coefficient matrix, right? And then, so we set everything up the same way, 9, 4, 6, right? So what we're going to solve is, we're going to solve the augmented matrix. So this is called the augmented matrix. Augmented with the right-hand side, right? And what we're going to do is we're going to reduce this, right? We're going to reduce this using row operations. And then at the end, whatever we have, we can now solve that system to find x1, x2, x3. I think that sounds good. Now, let's see, what's the first row operation we're going to do? So it's very difficult to use this to reduce the rest of the rows. So the first thing is we switch R1 for R3, right? So the first thing is what we switch R1 for R3. And this makes our life much easier, right? So here will become 6, row 2 remains, and row 1 becomes row 3. Okay, good. Now from here, what do we do? Now we can start reducing. So we know that what minus 3 R1 plus R2 would reduce R2, and then minus 2 R1 plus R3 will reduce R3. So notice that we're trying to make this entry 0. We're trying to make this entry 0. So now what do we have? We didn't touch R1, so this remains. So minus 3 R1 plus R2, this would become 0. Then minus 3 times minus 4, that would be plus 12, plus 2, that would be plus 14. Then minus 3 times 2 is minus 6, minus 1, that's minus 7, minus 3 times 6, minus 18, plus 4, that's minus 14. Okay, good. So what do we do next? The next one, right? So minus 2 R1 plus R3. So minus 2 plus 2, that's 0, plus 4 minus 3, that's 1. Is that correct? So that's, not plus 4. So minus 2 times minus 4, that gives us plus 8. Plus 8 minus 3, that's 5, plus 5. Then 2 times minus 2, that's minus 4 plus 2. Minus 4 plus 2, that's minus 2. And finally, minus 2 times 6, that's minus 12 plus 9. Minus 12 plus 9, that's minus 3. Okay, good. Now we move to the next one. So the next one is we make this, the first entry, the first non-zero entry in the second row, we make it 1, right? So we divide this by 1 over 14 R2. That way we can easily use R2 to reduce R3. So this is the logic behind that, behind doing this. To make it easier, so minus 7 divided by 14, that's minus 1 over 2, and then minus 1. We haven't touched R3, so it remains. Now we can touch R3. We use R2 to reduce R3, which is minus 5 R2 plus R3. Now what do we have? We have 1, 4, minus 4, 2, 6. Then what do we have on the second row? We haven't changed this, so this remains. And finally, on the last row, what do we have? We have 0, minus 5 times 1 times plus 5, that will give us 0 as well. And then minus 5 times minus 1 over 2, that's 5 over 2. So we have 5 over 2 minus 2, that will give us 1 over 2. Okay, so that's 2.5 minus 2, that will give us half. And finally, minus 5 times minus 1, that will give us 5. 5 minus 3, that's 2. Okay, so now you can see we've reduced this. So this means that the initial problem set that we have is similar to solving this. So this is what it means. Our initial problem is equivalent to this coefficient matrix and the column vector on the right-hand side. Okay, so now it is easier to solve this. So what we basically do, we multiply through, that gives us x1 minus 4x2 plus 2x3 equal to 6. X2 minus 1 over 2 x2 equal to minus 1, and then 1 over 2 x3 equal to x3. So we'll start, equal to 2, sorry. So we'll start from solving this. This means x3 is equal to 4. Very easy, right? Cross multiply, you get x3 equal to 4. Now substitute this into solving this. What will happen is, so let's just shift this to the right-hand side. So what does that mean? It means x2 minus 4 over 2, which is 2, equal to minus 1, which means x2 equal to 2 minus 1, which is 1. So x2 will be equal to 1. And finally, we can solve this, which is x1 is minus 4 times x2. 4 times 1 is 4. Is 4, so minus 4 plus 2 times 4, which is 8, equal to 6. So if you solve this, this means x1 equal to 6. This is plus 4 here, 6 minus 4, which is equal to 2. So our solution set is x1 is 2, x2 is 1, and x3 is 4, right? Which is the same thing that we got using LU decomposition, right? So that brings us to the end of the video. I will see you guys in the next one.